So today we will investigate elements, atoms, and the periodic table. Now, many of you have seen this table. It's a very popular one in science. It's basically got a particular order to it and a whole bunch of different symbols, numbers, and names. Now, as you can see in this diagram here, we've got usually a symbol for most of the elements. Now, the elements are just the different types of building blocks of matter that exist on our planet anyway. So, you know, we can see that we've got a element called hydrogen. And hydrogen has, unique qualities, unique features that are just unique for hydrogen. Now, that's the name of the element, hydrogen. We won't really discuss what this means, the atomic mass. You do need to understand that each, to just make things simple or maybe more complicated, each name has a particular symbol associated with it. And in my opinion, it's best to know the first 20 symbols by memory, especially in year 11. In year 12, you might need to know a few more. So we've got hydrogen, and there's an atomic number as well. Now, the atomic number is also referred to as the number of protons. Number of protons. Okay, so if you look at hydrogen, what you know is that in the nucleus of the hydrogen, hydrogen just has one proton. If you look at, say, iodine, which is down here, iodine has 53 protons in its nucleus. Okay, so that's essentially what makes it iodine. If an element, if an atom has 53 protons in its nucleus, it will always be iodine. Okay, so the number of proton and the atomic number are related. Okay, so now it's not an accident the way that this periodic table is designed. There is a particular order to it, and in future lectures we'll have a look at what the order actually is, etc. Two of the things that we might need to look at today is something known as the group and another idea known as the period. And this will come up in our lecture today. So if you want to know what a group is just going down the actual periodic table. So that's what a group is. So one of the features about a group is that all the elements down a group have similar properties. And we'll discuss what this means in a moment. I don't want to really overwhelm you. As we go across, if I can select the color, as we go across, say, doesn't matter which line we take, that's known as the period. Okay, as we're going across, I'll try to organize. So the group goes down and the period goes across. Now, let's have a look at the significance of this group and period and how it actually defines the structure of an atom. Now, let's pick a particular element from this periodic table. Let's say I'll choose aluminium. Now, I've just ruined it because you can't actually see the number at the top, but it is 13. Dark gray, black. Okay, so let's see what we know about aluminium. Aluminium is its atomic number is equal to 13. And remember, just before we discussed the atomic number being related to the number of protons. So that means that aluminium has the proton number is also 13. It has to be the same, always. Okay, so that's what we know about aluminium. We know how many protons it has inside of its nucleus. Now, another thing about aluminium is we also can tell how many outer electron shells aluminium has. Okay, so we know that every atom, no matter what it is, has a nucleus. So this is my nucleus. I'm just going to put aluminium there. I'm not going to draw out the 13 protons because it will probably take up too much space and it's too complicated at the moment, but we will have a look at this in later on. So aluminium, let's say that that's its central nucleus. And if we look at the position of aluminium in the periodic table, we can see that it is, so position, that's the first period, this is the second period, and this is the third period. So 1, 2, 3. So aluminium is located in the third period. So what that means, that's very important information, because what that means is that aluminium actually has 3 electron shells around it. And it's a bit difficult to draw them out. So 3 electron shells. So that's not really an electron shell there, that's just my nucleus in the center. Okay, so 3 electron shells outwards. Now, another thing that we can kind of figure out about aluminium is how many electrons are within each shell. Okay, so if we have a look at the first period, and you kind of go horizontally, so you can see hydrogen there, then you can see helium here. What that means is the very first 2 shells in aluminium, the very first shell in aluminium, sorry, has 2 electrons present in it, because as you go across the group, as you go across the period, the significance of going across the period is that more electrons are being filled within that shell. Because remember, the first period looks at the very first shell. So that's the first shell. And you can see that it's to get eventually to aluminium, first you have to fill in the first 2 electrons, right? Then as we go to the second shell, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8. So in the second shell, there are 8 electrons present. So I'm just drawing these electrons here. Okay, so that's filling in the second shell. So I'm just gonna, so each of these have an important effect on the actual structure of the atom. Well, in this case of the element aluminium. And finally we get to the third shell. We look at sodium. I've just ruined that a little bit, but let me just get rid of. Okay, so we can see the third shell needs to fill up until it finally gets up to aluminium. Whoa. I don't know what I just did, but that looked okay. So we have to get up to aluminium. So what that means is that in the third shell we have 3 electrons. So 1, 2, 3. And you might be wondering why I clustered the electrons close together in this shell, but then I spread them apart in the final shell. The main reason why is because when you do have a full shell of electrons, you kind of pair them up in 2s. But when you have an incomplete electron shell, like here, you actually spread them apart, because putting electrons together remember that they're negatively charged. If you place them side by side, they're going to repel. So in order to minimize the amount of electrostatic repulsion, we actually spread them around the electron shell. And I will show you with another example how this also works. Okay, so that's basically aluminium there, and this shows all the electrons surrounding it. So you might be asked to write out something called the electron configuration. Electron configuration. And the electron configuration, the very basic one, is just for aluminium. It is just looking at how many electrons are in the first shell of aluminium. So you would write 2, then you would have a comma. The next one would be 8, then comma again, and then in the last shell we have 3 electrons. So that is the electron configuration for aluminium. Now let me just try to find another example. We'll do another example. Let's pick something. Now I'm going to pick only the first 20 elements because I don't really want to overcomplicate things. So let me just clean this up a little bit. We might choose something like maybe chlorine. So actually maybe something else. Let's just choose fluorine. So fluorine's right here. Now, so fluorine, its atomic number is equal to, if we just go back to it and have a look what it's equal to, from the periodic table you can see the little number 9 up there, and so fluorine has 9 protons in it. Okay, and we can straight away assume that, but atomic number equals to the same thing as the proton number, which is in this case equal to 9. Okay, now there's going to be a bit of flicking back and forth because unfortunately the screen size is limited. It's a bit hard to see my mouse. Okay, so if we look at the position of fluorine in the periodic table, one of the things that we see is that fluorine is in the second period. Okay, because it's in the this is the first period, that's the second period. Okay, so fluorine is positioned in the second period and in the second row, and so we can tell something about the number of electron shells that fluorine has. It's got 2. Okay, so let's go back. A bit frustrating. I will have to fix my mouse because it's not cooperating. But if I again make the central nucleus just the F with a circle around it, that's my nucleus. There's a lot more happening in there than we know, but I just will put a symbol there just to make things easy for now. And then we know that fluorine has 2 electron shells around it. Okay, and that's good. And now we have to have a look at how the electrons are actually organized. So as you probably remember, the first shell has 2 electrons because it's hydrogen and then helium, and then that period finishes. Okay, and then the second shell, if we have a look at fluorine and how to get to fluorine, so this is the first shell, fills up 2 electrons, and then the second shell fills up 1, 2, 3, 4, 5, 6, 7. So it has 7 electrons in the second shell. Okay. Now, so let me just draw that in. So I'm going to first draw them apart like this. 1, 2, 3, 4, and then I'm going to get up to 7. 5, 6, 7. Okay? So if we look at the electron configuration, it is actually 2, 7. Okay? So that's how we draw out the element fluorine. Finally, we'll do one more example. Excuse me while I can't find my mouse, it's just not cooperating, but I will fix it. Let's pick up another one. Let's say, I'm not going to go into the transition metals because that's where it gets pretty complicated. Let's do perhaps potassium. Now potassium, if this periodic table was a bit bigger, maybe you have one in front of you. Potassium is this element here, and so we can see that it is actually in the 4th period. Okay, so it's 4 rows down. That allows us to understand the structure of the electron shells around the nucleus. So potassium has 4 electron shells. So finally. Okay, so if we write out potassium, we also know that the atomic number, which is also the proton number, is equal to 19. Okay, and again I'm going to draw out the potassium in the center, that's the nucleus, and then one shell, 2 shells, my shells are getting worse, 3 shells, and then finally 4 shells. I have to get very good at drawing circles in this in chemistry. Okay, so the first shell always contains 2 electrons. Okay, then the next shell, if we have a look, the next shell has, we'll just try to remember this. So the next shell has 8. You can see as you go across, 1, 2, 3, 4, 5, 6, 7, 8 in the next shell. The third shell has also 8. Okay, because it's completely full in order to finally get to potassium. Okay, and as you can see in potassium, it's in the very first group. What that means is that potassium only has 1 electron in its outer shell. The outer shell has a special name, it's called the valence shell. Okay, so let's remember that. So 8 in the second shell, 8 in the third shell, and just 1 in the 4th shell. Okay, so let's go back here. Our shells are nicely drawn out, and we'll put in 1, 2, 3, 4, 5, 6, 7, 8. Again, in the third shell there's 8. So I'm because I know that the full shells, I'm just going to draw them together, and then finally the last shell, it just has 1 electron. Okay, so the electron configuration is, in this case, 2, 8, 8, 1. That's the electron configuration in its most simple form. Okay, so one of the things that is useful about the periodic table is it gets you to understand, it allows scientists to understand exactly how many electrons a particular element has and how many electron shells it contains. So you can tell that information by looking at the periodic table. Now, the reason why we want to draw these structures out, to draw out the actual atom, is so that eventually you can understand what sort of the electrons are doing in that element. So if you have a look at, as I said before, I did introduce the group and the period. The period was just basically telling you how many shells something contains. The group, if we look down here, this first group, what we understand about the group, I did specify that they have similar properties. All these elements down the group have similar properties. And the reason why they have similar properties is because they all just have one electron in the outermost shell. Okay? See, potassium has one electron, which we just drew out, in its final shell. So does sodium. Sodium has one electron in its final shell. The difference between potassium and sodium is that sodium actually only has 3 shells because it's in the third period, whereas potassium has 4 shells because it's in the fourth period. But both of these, potassium and sodium, have only one electron in the outer shell. And electrons are essentially the things that rule the property of that particular element. So all of these, because they only have one electron in the outer shell, they behave in similar ways. They're not identical because of course they have different sizes and different number of shells, but you can be sure that they have similar properties, similar behaviors. If we look at, say, this group here, this group of elements here, this group of elements down there, again, you can be sure that they have the same number of valence electrons as you go down the group. They have similar properties as a result, but they don't have the same size. So oxygen at the top there, oxygen only has 2 electron shells. Sulfur, as we go down, has 3 electron shells. Psyllium has 4 electron shells, and so forth. We go down the group, and basically the size of the atom just gets bigger and bigger. So that's a special way in which groups are arranged. So it's not just random. And of course, as we go across the period, there are more electrons that are being filled. Okay, so finally, I just wanted to show you a last example of perhaps how helium or maybe hydrogen is drawn. So as I did mention that hydrogen has only one atomic number, one as its atomic number, and so it just has one proton in its center. So we might actually do hydrogen and helium. So hydrogen is H, and it's in the first group. So this is my nucleus. Okay, don't confuse that with the electron shell. It's my nucleus, and then the first electron shell. Okay, and because hydrogen has an atomic number of 1, that means that the proton number is 1 as well. And also, if we look at hydrogen, it's the very first one in the periodic table, so it's just essentially 1 electron in that shell. So its electron configuration is just simply equal to 1. On the other hand, helium still has 1 electron shell, right? But the atomic number for helium is equal to 2, and so you've got 1 and 2 electrons, and we bunch them together because that's the that first electron shell is now completely full, if you wanted to go to the next element, say to atomic number 3, you would have to have another electron shell. So you would have 2 electron shells this time. So the first electron shell only contains a maximum of 2 electrons. Okay? So basically the periodic table, it's important to understand that it's organized in groups and periods. The groups have similar properties, the same number of valence electrons. The period is telling you how many shells that element has, and the amount of the number of electrons in that shell. So it's very important to understand how that relates, these patterns relate to the structure of an element.